Hello folks, Paul here, UK Rails and More. Hope you're all keeping safe and well. You may be asking yourself, what is this we're looking at? And that would be a very good question. Well, there you go on the top, the Pooley's CRP-5 computer. Now, a couple of videos back, 2 or 3 videos back, I asked if people would be interested in seeing a bit more aviation themed items, and a few people said that they would. So yeah, appreciate this may not be everybody's bag, but if it is, stay tuned. I'll explain a little bit more about this. If not, worry not, there'll be certainly be more Rails stuff coming up very soon. Okay guys, so let's take a bit of a closer look at this quite amazing piece of kit. I'm sure you'll be really impressed with this. It's something, when I first looked at it early on in flight training in ground school, we were all quite amazed by it, but equally slightly fearful of it because it looks incredibly complicated, and it can be, but once you get to know it, it can do all manner of things. So this side basically is a computer on this side, not the Microsoft ones you'd be maybe used to, but yeah, a real old piece of kit. In one format or another. It was invented years ago. These were certainly around in the time of the Second World War, and the old navigators and pilots would have used them back then for flight planning, and also on board the aircraft for certainly the navigators anyway. So yeah, on this side of it, on this round section of it, you can see there's all manner of conversions that you can do on there. So it will do conversions between different things, yards and meters and gallons and fuel, various altitude, airspeed, lots and lots of different calculations. Really does look, even temperature calculations you can do. You've got this this marker moves along, so you can do certain calculations and the conversions depending on your setting. Okay, I wasn't going to go into that too much. That might be a bit heavy for some people. What I was going to do is something that may be practically a little bit more interesting, and certainly a practical calculation that I would use for flight planning on any route, whether that be as part of the training or if you were doing your own flight from A to B. You'd certainly use this for your wind calculations. There are other ways of doing it as well. There's modern apps and various other sites that you can use to get that information. However, it does work. It's an ideal backup, and I've used it many times before. So basically, we'll go and explain a little bit about that. So we've seen that side. The other side is the one we're going to be having a look at today. Okay. So on there, you've basically got various different headings and various different drift settings, and you've got this compass rose, okay, that basically revolves around, and I'll explain how that works and it'll become a little bit more apparent. So I'll explain that, but there you go, northeast, yeah, north. We've got north on the top on the outer scale. So what we'll be doing, I'll explain it a little bit more, but basically this whole thing slides along the scale. Okay, so on the other side, you're just using it for this section. Okay, this is the bit that you use. But for this, certainly working out wind calculations, heading calculations, you use this sliding scale. Okay, it will become a little bit more apparent. Okay, so let's just have a look why we'd use it first of all. Okay, so to try and explain this, if we're planning a flight and we're going from point A, so we take off from point A to point B, and we've got no wind at all, then generally the track that we've got there is 045 degrees. So position B is 045 degrees from position A. If you imagine that on the compass, so there's north, okay, 90 degrees over here, 45 degrees over there. Now in still air, the heading that we would actually have on the aircraft, i.e. the position of which way the aircraft is pointing, that's the heading. The track over the ground is the track. So in still air, where there's no wind at all influencing that aircraft's passage through the air, then the track would be 045, that stays the same. The heading would also be 045 because the aircraft is just going to point in the same direction and go through the air. Okay, but what happens when we've got a bit of wind? So say we've got a strong wind coming in this direction. Well, if that wind was coming in this direction here, just to show you, then that aircraft would gradually be pushed off this way. I'll try and explain that. So gradually that aircraft would be blown over to one side because the air is having an effect on it. So we'd end up somewhere south of position B, where we want to get to. Okay, so when we've got the wind, the aircraft needs to fly a different heading. Remember, the heading is what we're pointing at the front of the aircraft. So we need to fly a little bit into wind. And what that will do is it will mean that the aircraft will maintain, once we've got the calculation for that heading, the aircraft will maintain that track across the ground. So we still get to destination B. Okay, so still air, we're just going to point straight at it. So the heading will be the same as the track. When we've got some wind, we need to point into the wind to a certain degree. The stronger the wind, the more we need to point into it. A very light wind, we'd only need to point into it a little bit. But we're doing that so that the aircraft covers the same route over the ground, even though the heading has changed. Hope that makes sense. Okay, so that's where the computer comes in. We've still got that track. We need to cover from a 045 over the ground. So what's the heading? And that is the beauty of the flight computer. So I'll show you a little bit of how that works. Okay folks, so basically we're going to use the computer, the flight computer, and we're going to use it to calculate which heading we should be flying, okay, to maintain that track. And that will also give us a ground speed, the speed, so we can work out how long it's going to take us to get there when we take into account this effect from the wind. So I'll show you how that's done. Now the first thing we need to input into this is the actual wind, and we need the wind direction and the wind speed. So basically, if we've got the wind is flying down in this direction, okay, well, we say where is the wind coming from. So that wind is coming from say 350 degrees, and let's say for instance it's 20 knots. Okay, so that's our winds, and that's the way it would be written. So I'll show you how we put that into the computer. Okay guys, so back at the computer. So the first thing we do, bear in mind this is a sliding scale, so we can slide this up and down. It is a bit more difficult with one hand, but we can do that. So the first thing we're going to do, we're going to input the wind details. So if you see at the centre of the screen there's that little blue dot. We line that up on the very centre line like that. The next thing we do, we turn around the top to give our wind direction, the 350, and we line that up with the little marker arrow at the top there. Okay, so that's 350. We've got that dot on the centre, and then what we do is we put in the wind speed, which is 20 knots, 20 knots. Use a pen. Okay, and we mark a little dot, very fine little dot on the 20. There you go, right on the centre. Needs to be accurate, this. Okay, so the next thing that we do is we need to slide the identifying the main blue marker dot. We need to slide that up to our aircraft's airspeed. Okay, I'll explain a little bit more about airspeed in a moment and ground speed, but basically, if we just do it, we slide that up to, say for instance, our aircraft has a cruise speed of 120 knots. Okay, so there's the dot on the 120 knots. Now, airspeed is the speed that the aircraft passes through the air. It's not the speed that it necessarily carries over the ground for the journey time, but it's the speed that aircraft passes through a segment of air. So that's what we put in. So that's the cruise speed of the aircraft for the airflow that goes over the wings. But I'll perhaps explain a little bit more about that in another video if this one goes down well. Okay, so the next thing that we need to do is we need to put in the track that we require. So I'll show you how that's done. Okay, so just going back, our track across the ground, i.e. this direction here, is 0.45 degrees. So we put that into the computer at the top, and we do that by revolving the sliding wheel to align 0.45 with the marker at the top. So that's lined up. Now as we've revolved that round, we've seen that the red dot that was down here, bear in mind that's still on 120 knots, the airspeed, has moved off to one side, okay? And we can see that that's moved over to the right and is showing 110, 115, about 119, because each one of these represents 5 degrees. So 119, say it's actually in between 118 and 119, which is, say for instance, 9 points to that side. So the thing is, what we do now is we mark the centre there. Okay, and then we turn this in the direction that the dot moved off by 9 degrees. Okay, it was just in between the 8 and the 9, so let's put it there just for argument. And what we do is we re-inspect that dot. Now you can see there that that's moved further off to the left. Okay, it's moved about half a degree to the left. Okay, so let's move this slightly to the left, half a degree. So if we can just go, so it's gone to there. Okay, so that's moved over to 8 degrees right drift, and we check this, and now that dot there matches 8 degrees to the right and 8 degrees to the right. Now if that dot was off in the opposite direction too much, we'd keep moving until, just shuffling very slightly until we get the dot in relation to here being 8 degrees drift and the dot being 8 degrees drift to here. And once we've got that aligned, we're now able to take the reading, because this is what the magic of this machine. Okay, so this gives us our heading. Okay, so we measure it from the bottom here. So there's 30 degrees, 35 degrees, 36, 37 degrees. Okay, so 037 degrees is the heading that we want. Okay, so that means, bear in mind the track, the heading with still air would have been 045 degrees. With the wind now having an effect, it means instead of pointing 045 degrees, which would be up here, we need to point the aircraft heading to 037 degrees. So 037 degrees we fly towards, the aircraft will track to take us to point B. Clever stuff, but it gets cleverer still because we're also going to get the ground speed from this device as well. Okay, so all we do is we look at where the red dot has moved to, and we can see that that red dot now, if we work along this line, so that's 100 knots, that's 110. So these go up in increments of 2. So 112, 114, 116, 118 knots. Okay. So 037 degrees at 118 knots. Okay. And that means that the speed that we are going to pass over the ground, bear in mind the airspeed was 120 knots. The speed at which the aircraft passes over the ground is going to be 118 degrees, 118 knots, which we would expect because it's going to be slightly slower because we are flying slightly into wind. Okay folks, so I hope you found that interesting. It does take a while when you're trying to explain it and you're using just one hand, but when you're using both hands and you're up to scratch with it, then yeah, it takes about 30 seconds, the whole process. But yeah, I'm sure you agree it's quite an impressive piece of kit. If you like that, I'd be really grateful if you could give the video a thumbs up, because that would really help. I will do more aviation themed stuff if it's popular, but also there'll be plenty more rail stuff coming up soon as well. So yeah, thanks very much for watching, and take care, and I'll speak to you very soon.